Jupiter, the undisputed giant of our solar system, is so massive that Earth could fit inside it more than 1,300 times. But despite its colossal size, Jupiter is a surprisingly fast spinner, completing a full rotation in just under 10 hours. This rapid spin fuels its violent storms and turbulent atmosphere, making it one of the most dynamic worlds we know. Its powerful rotation generates intense jet streams that sculpt its famous bands, vast belts of clouds moving in opposite directions, creating a mesmerizing pattern across the planet's face. These bands are not static. They shift, evolve, and interact with the planet's deep atmosphere, a churning ocean of gases where the forces of physics play out on an unimaginable scale. The Great Red Spot, a swirling tempest larger than Earth, has raged for at least 400 years. With winds reaching 680 kilometers per h, it's a storm of unparalleled ferocity. Yet, recent observations reveal that it's shrinking. Could this be the end of the solar system's most famous cyclone? Scientists are watching closely, analyzing its structure, trying to predict its fate. What keeps it alive? Why has it persisted for centuries while Earth's hurricanes dissipate in weeks? Some theories suggest that Jupiter's deep atmosphere provides a source of continuous energy, feeding the storm from below. Others speculate that interactions with surrounding jet streams reinforce its rotation, keeping it spinning indefinitely. And yet, the shrinking diameter hints that something is changing. Perhaps we are witnessing the slow death of a planetary giant. Jupiter's birth was a cosmic event of monumental proportions. Studies suggest it formed within just 1 million years after the solar system's birth, growing to 20 Earth masses before reaching its final form. It was the first planet to emerge, shaping the destinies of all that followed. The very presence of Jupiter may have determined the fate of the inner planets, influencing their orbits and possibly even clearing away material that might have formed additional worlds. Some simulations suggest that Jupiter's migration during its infancy caused catastrophic collisions among planetary embryos, drastically altering the landscape of the early solar system. In a sense, Earth and the other rocky planets may owe their existence to Jupiter's chaotic early movements. Like the Sun, Jupiter is mostly hydrogen and helium. Had it been 80 times more massive, it might have ignited nuclear fusion, becoming a second star in our system. Instead, it remains a failed sun, an insight into how planetary systems evolve. But despite its failure to become a star, Jupiter still emits more heat than it receives from the Sun. This internal heat source drives massive storms and atmospheric turbulence, creating a world that is constantly in flux, never static, never at rest. The heat also hints at a mysterious interior where pressures and temperatures soar to extremes beyond our comprehension. Astonishingly, Jupiter and the Sun orbit a common center of mass, just outside the Sun's surface. This gravitational dance is a testament to Jupiter's immense pull, a force that subtly tugs at the very fabric of our solar system. No other planet exerts such influence. Its gravity shapes the orbits of countless asteroids, moons, and comets, sculpting the architecture of the solar system in ways we are only beginning to understand. Jupiter is, in many ways, a celestial architect, an unseen hand guiding the motion of worlds. Jupiter boasts at least 95 moons, a mini-planetary system in its own right. Among them, Europa stands out, a world with a subsurface ocean that may harbor extraterrestrial life. Future missions like ESA's JUICE and NASA's Europa Clipper aim to explore its secrets. If life exists beyond Earth, Europa might be our best chance of finding it. Beneath its thick ice shell, a global ocean swirls, kept warm by tidal forces exerted by Jupiter's massive gravity. Could this be an alien cradle, a hidden refuge for microbial life in the depths of the cosmos? Jupiter acts as Earth's cosmic shield, deflecting comets and asteroids that might otherwise strike us. However, its gravity can also hurl objects inward, potentially triggering catastrophic impacts. A double-edged sword in the celestial battlefield, its role in Earth's history is complex. Some scientists speculate that Jupiter may have played a role in delivering water to Earth, guiding icy comets into the inner solar system. Others wonder if its gravitational influence has periodically unleashed waves of destruction, sending asteroid swarms toward our planet in cycles spanning millions of years. Jupiter's migration reshaped the solar system. Initially forming farther out, it moved inward, disrupting the planetary nursery. This chaotic journey may have been instrumental in Earth's formation, sculpting the conditions necessary for life. Without Jupiter's wandering path, our solar system might have looked very different, perhaps lacking rocky planets altogether, or harboring super-Earths in places where we now see only empty space. Jupiter's atmosphere is a masterpiece of fluid dynamics. Its iconic bands, alternating light zones, and dark belts are shaped by powerful jet streams. What causes their distinct colors? A complex interplay of chemistry, temperature, and unknown elements. Scientists believe that the deeper we go, the more alien Jupiter becomes. Beneath the visible clouds, ammonia ice gives way to ammonium hydrosulfide and eventually to a deep layer of water clouds. But what lies below remains one of the great mysteries of planetary science. Jupiter's magnetic field is 20,000 times stronger than Earth's, generating lethal radiation belts. Any spacecraft venturing too close risks being fried by this invisible force field, making exploration a formidable challenge. The Juno mission, currently orbiting Jupiter, has had to navigate these deadly regions carefully, revealing astonishing insights about the planet's interior and magnetosphere. Lightning storms on Jupiter dwarf anything on Earth. Its bolts flash with up to 1,000 times more energy than our planet's storms, hinting at complex and violent weather patterns. These storms provide glimpses into the deep atmospheric layers, where pressures crush anything we might send to explore. Jupiter's poles glow with aurora far more powerful than Earth's northern lights. Fed by volcanic emissions from its moon Io, these dazzling light shows provide insight into planetary magnetospheres beyond our own. Jupiter has rings. Though faint compared to Saturn's, they are made of dust kicked up by meteoroid impacts on its smaller moons, a subtle but fascinating feature of this gas giant. Jupiter remains an unfinished story, a celestial enigma still holding secrets. With new missions en route, we stand on the brink of discoveries that could reshape our understanding of planetary science, the formation of worlds, and perhaps even life itself.